August 11th, 2025. Rocket engineers around the world just watched SpaceX do something they swore was physically impossible. For 8 years, every single Falcon Heavy center core crashed and burned. Literally. The physics were brutal. Twice the weight, 3 times the heat, coming down like a meteor at 5,000 miles per hour. NASA engineers called it suicide mission for any booster. But then SpaceX pulled off a landing so perfect it broke the internet. What did they discover that rewrote the laws of rocket recovery? And why are competitors now panicking about their billion-dollar programs? Let's dive right in. Here's the brutal reality that made engineers call this landing impossible. A Falcon 9 booster weighs 25 tons empty when it comes back down. But a Falcon Heavy center core? It weighs 50 tons, literally twice as heavy. That's like the difference between a pickup truck and a fully loaded semi-trailer hitting your driveway at 200 miles per hour. But weight was just the beginning of this engineering nightmare. While side boosters get to shut down early and coast back like gentle parachutes, the center core stays attached, burning fuel and accelerating the entire stack higher and faster. By the time it finally separates, this beast is screaming through space at over 5,000 miles per hour. That's faster than a rifle bullet, times 7. When something that massive hits Earth's atmosphere at hypersonic speeds, the laws of physics become merciless. The air compression creates temperatures exceeding 3,000 degrees Fahrenheit, hot enough to instantly vaporize aluminum. The structural stress reaches levels that NASA engineers nicknamed the meat grinder. This isn't just heat. This is the kind of punishment that turns aerospace-grade steel into glowing plasma. Why did SpaceX keep trying when every attempt ended in spectacular failure? Because they weren't just trying to save money. They were trying to prove something that would fundamentally break the entire global space industry. Let me paint you a picture of systematic destruction that haunted SpaceX for nearly a decade. February 2018, first attempt, the center core slammed into the Atlantic Ocean at 300 miles per hour, creating a water explosion visible from the drone ship miles away. $90 million worth of cutting-edge rocket technology disappeared beneath the waves in 3.2 seconds. But here's what makes this story truly insane. SpaceX employees were actually celebrating that crash. Why? Because for the first time, they'd gotten useful data about center core reentry. The booster transmitted telemetry right up until impact, sending back information about heat, stress, and aerodynamics that they'd never captured before. April 2019, second attempt. This time the center core actually reached the drone ship. For exactly 2.8 seconds, it looked like the impossible had happened. The booster was upright, engines were throttling down, landing legs were deploying. Then catastrophic engine failure. The 16-story rocket toppled sideways and exploded with such force that it damaged the recovery ship's deck equipment. The pattern was always identical: perfect launch, flawless mission execution, then physics-defying destruction during the final 30 seconds. But here's what the public didn't know. Each failure was teaching SpaceX something that would eventually change everything. June 2019, third attempt, another ocean grave. But this time, engineers noticed something strange in the telemetry data. The center core was actually performing better than expected during re-entry. The problem wasn't the rocket, it was the timing. Here's where this story gets absolutely wild. Each Falcon Heavy launch burns through $90 million worth of boosters. If SpaceX could recover all 3, those same rockets could fly 10 more times. Basic math, that's $900 million in saved hardware per booster set. But multiply that across hundreds of planned missions, and you're looking at tens of billions in cost advantages. But there was a deeper, more sinister game happening behind the scenes. SpaceX wasn't just trying to save money. They were trying to create a monopoly so complete that every other rocket company on Earth would become obsolete overnight. Think about the implications. Blue Origin has spent $7 billion developing New Glenn, betting their entire company on reusability. ULA is desperately trying to add recovery systems to Vulcan. China's space program is throwing billions at copying SpaceX's landing technology. Every major space power is racing to master rocket reusability. If SpaceX could prove that even the most punishing, most impossible recovery scenario was solvable, it would demonstrate that literally any rocket could be reused. That would make every competitor's expendable rocket program look like throwing money into a furnace. But then something bizarre started happening in SpaceX's mission planning that made industry analysts think Musk had finally met his match. By 2023, SpaceX seemed to quietly give up on center core recovery. Mission after mission, they'd save the side boosters, but let the center core crash into the ocean like expensive fireworks. Space industry newsletters started running headlines like "Even SpaceX admits defeat" and "The physics problem Elon can't solve." Boeing executives were privately celebrating. Blue Origin started talking more confidently about competing with SpaceX. The entire aerospace establishment breathed a collective sigh of relief. Finally, something SpaceX couldn't do. But here's what nobody realized. SpaceX was playing a completely different game. While everyone focused on their public failures, Musk's engineers were secretly conducting the most expensive physics experiment in human history. They were turning $90 million center cores into disposable research instruments, gathering data about extreme re-entry conditions that would inform their next-generation Starship program. Every failed center core was actually a data collection mission. They were learning about materials science under impossible conditions, testing heat shield technologies, and gathering information about supersonic aerodynamics that you simply can't get any other way. They were essentially using failed center cores as $90 million wind tunnel experiments. But the real breakthrough came when SpaceX realized they'd been approaching the entire problem backwards. By 2023, SpaceX seemed to quietly give up on center core recovery. Mission after mission, they'd save the side boosters, but let the center core crash into the ocean like expensive fireworks. Space industry newsletters started running headlines like "Even SpaceX admits defeat" and "The physics problem Elon can't solve." Boeing executives were privately celebrating. Blue Origin started talking more confidently about competing with SpaceX. The entire aerospace establishment breathed a collective sigh of relief. Finally, something SpaceX couldn't do. But here's what nobody realized. SpaceX was playing a completely different game. While everyone focused on their public failures, Musk's engineers were secretly conducting the most expensive physics experiment in human history. They were turning $90 million center cores into disposable research instruments, gathering data about extreme re-entry conditions that would inform their next-generation Starship program. Every failed center core was actually a data collection mission. They were learning about materials science under impossible conditions, testing heat shield technologies, and gathering information about supersonic aerodynamics that you simply can't get any other way. They were essentially using failed center cores as $90 million wind tunnel experiments. But the real breakthrough came when SpaceX realized they'd been approaching the entire problem backwards. Within 24 hours of that landing, the global aerospace industry experienced what analysts are calling the biggest market shock since a Sputnik. Blue Origin's stock dropped 15%. ULA postponed 4 launches to review recovery procedures. 3 Chinese space companies canceled IPO plans. Russia's space agency held emergency funding meetings. Why the absolute panic? Because SpaceX had just proven that the most expensive, most challenging part of rocket reusability, the part that every expert said violated the laws of physics, was actually solvable with existing technology. But the real earthquake came 48 hours later when aerospace intelligence networks started reporting what they'd heard through back channels. SpaceX wasn't planning to retire the center core. They were planning to strap it back onto a Falcon Heavy and attempt the impossible, landing it again after a full triple booster mission. That's when the industry realized the true scale of SpaceX's strategy. This wasn't just one successful landing. It was proof of concept for making Falcon Heavy 90% reusable instead of 67% reusable. At that reusability rate, SpaceX could launch heavy payloads for less than competitors could launch small ones. So what exactly did SpaceX change to make this work? The answer involves 3 engineering breakthroughs that sound like science fiction, but are absolutely real. First, the grid fins got a secret upgrade. These steering fins now use a new titanium vanadium alloy that can withstand 25% more thermal stress than previous versions. That seemingly small improvement created just enough stability margin for the heavier center core to maintain control during the plasma-filled hell of atmospheric re-entry. Second, The landing sequence uses a completely new four-engine startup pattern instead of the traditional three-engine approach. But here's the genius part. The engines fire in a specific rhythm that creates acoustic interference patterns, actually helping to stabilize the rocket's descent through turbulent air. Third, and this is the breakthrough that made materials scientists worldwide rethink their assumptions. SpaceX developed real-time adaptive flight software that constantly adjusts for the center core's changing mass as it burns fuel. Previous attempts were essentially flying blind, using software designed for much lighter Falcon 9s. These modifications sound minor, but in rocket engineering, minor tweaks separate success from becoming a very expensive firework display. SpaceX had just proven they could make these modifications work under conditions that push the absolute limits of material science. At exactly 8 minutes and 27 seconds after liftoff, Center Core B-1067 touched down on the drone ship, "Of Course I Still Love You," with such precision that it barely swayed on touchdown. The landing was so smooth that SpaceX engineers later admitted they thought their telemetry screens were malfunctioning. But here's what made this moment truly historic. SpaceX had simultaneously solved their biggest technical challenge while launching satellites for Amazon, their direct competitor in the satellite internet market. They were literally using Jeff Bezos's money to fund the technology advancement that would make Blue Origin's rockets look even more obsolete. The irony was almost comedic. The founder of Amazon was essentially paying SpaceX to develop technology that would further dominate the launch market, making it even harder for Blue Origin to compete. And Musk's team pulled it off with such casual precision that they made the impossible look routine. Space forums exploded with analysis posts reaching hundreds of thousands of views. The most popular question, what other impossible problems is SpaceX quietly solving while we're not watching? Within 1 week of the landing, the aerospace industry experienced what historians will likely call the SpaceX acceleration event. Rocket Lab announced they were moving their Neutron rocket timeline up by 8 months. Relativity Space started a massive hiring spree targeting SpaceX engineers. Most tellingly, China's space agency issued new directives making reusable rocket development the absolute top priority, above even their moon program. The message was unmistakable. SpaceX had just moved the goalposts again, and everyone else was desperately scrambling to avoid being left behind permanently. But the terrifying question for competitors wasn't whether they could copy this achievement. It was whether SpaceX was already working on breakthroughs that would make even this look primitive. Because if 8 years of center core failures had proven anything, it's that SpaceX doesn't just solve impossible problems. They make them look easy, then immediately start working on something even more impossible. And after watching this landing, every aerospace company on Earth was left with the same chilling realization. They weren't just competing with SpaceX anymore. They were competing with a company that had apparently learned how to break the laws of physics on command. The question that now haunts every boardroom from Seattle to Shenzhen isn't, how did SpaceX do this? It's, what impossible thing will they make look easy next? And based on their track record, the answer is probably something that will make this center core landing look like child's play. So here we are. SpaceX just turned 8 years of impossible failures into a single moment that rewrote the rules of physics. They proved that when everyone else sees limits, true innovation sees opportunities waiting to be unlocked. This center core landing wasn't just about saving money or beating competitors. It was about demonstrating that the gap between impossible and inevitable is usually just persistence, data, and the willingness to fail spectacularly until you succeed perfectly. But here's what keeps me up at night. If SpaceX can make center core recovery look routine, what other impossible challenges are they quietly solving right now? Orbital refueling? Mars landing? Something we haven't even imagined yet? The aerospace industry just learned that betting against SpaceX isn't just risky, it's career suicide. And for the rest of us watching this unfold, we're witnessing the exact moment when science fiction becomes tomorrow's reality. What do you think? Are we watching the birth of true space dominance, or is there still room for competitors to catch up? Drop your thoughts below. I read every single comment, And some of your insights end up shaping our next deep dives into the technologies that are reshaping our world. Thanks for joining me on this journey through the impossible. Until next time, keep looking up. SpaceX just revealed the shocking truth. Moon missions today are 10 times harder than 1969. Apollo used one rocket. Artemis needs 20 plus launches. Starship exploded 3 times while Apollo succeeded first try. The $90 billion question, how is primitive 1960s tech beating our advanced rockets? The answer will blow your mind. Let's dive right in. The numbers don't lie, but they hide a darker truth. Apollo 11's simple approach worked because we literally threw human lives at the problem until it succeeded. 3 astronauts burned alive in Apollo 1. The pure oxygen atmosphere that NASA knew was dangerous but used anyway turned their capsule into a crematorium in 17 seconds. But here's the shocking part. NASA didn't even pause. The Cold War pressure was so intense that dead astronauts were considered acceptable casualties. We weren't more advanced in 1969. We were more reckless. And somehow that recklessness made us faster. Compare that to today. SpaceX has lost 0 human lives, but has blown up 3 Starships in testing. Each explosion costs millions and delays the program by months. Why? Because in 2025, exploding rockets are unacceptable, but exploding astronauts were the price of winning the space race. Here's where SpaceX engineers discovered something that changed everything. Modern rockets are victims of their own sophistication. Apollo's computer had less processing power than your phone's calculator. When something went wrong, astronauts flew manually. Today's Starship runs millions of lines of code, each line a potential failure point that didn't exist in 1969. The Raptor engines powering Starship are engineering marvels that Apollo engineers couldn't have imagined. They operate at 300 bar of pressure with temperatures hot enough to melt steel. Apollo's F-1 engines were basically controlled explosions, crude but reliable. SpaceX's Raptor 3 engines represent the cutting edge of human technology. They're 3D printed with integrated cooling channels, produce 280 tons of thrust each, and